Okay, inverse trig functions. Well, we want to invert this. Of course, you can't invert it the way it is because it's not one-to-one. Obviously, it's very much not one-to-one. But we know we've dealt with this before. We dealt with it with y equals x squared. All we need to do is restrict the domain. So to invert, we need to restrict the domain. And this is simply a convention. You could restrict it to any domain on which it's one-to-one. So I could restrict it to here, or I could restrict it to there, or whatever. It doesn't matter. But because we all want to do something conventionally so we all can talk to each other, the conventional choice is to restrict it to this first bit from minus for sine to so that it's minus pi over 2 to pi over 2. So if I restrict the domain there, it means I don't need any of this stuff. Bye. Right? Now it looks kind of wonked, but all right, it looks like this. If you want a nice picture, look in the book or online. All right, so that's my picture. Now it's restricted from minus pi over 2 to pi over 2. It is now a one-to-one function, and I can invert it, right? So that's how I define the inverse. I define the inverse as y is the inverse sine of x, means that x equals sine of y, okay? So the domain is minus pi over 2 to pi over 2. Of course, my range is going to be minus 1 to 1 because that's the range of the sine function. So if I graph this, well, this is sine x. If I graph the inverse sine, then my domain is minus 1 to 1. My range is going to be minus pi over 2 to pi over 2. And kind of looks like this, right? That whole thing just kind of gets pulled over. Okay? And again, very useful to remember your unit circle points and all that. And you will have to, when you use these, if we're looking for something on another, should be a minus here. We're looking for something on another interval. No, that's the way it's going to be. You'll figure it all out. So I'm not going to go over all that stuff, which I'm sure you all remember from trig. So that is sine, cosine, sort of the same idea, right? It is the same idea. Looks like this, very bad picture. For sine, for cosine, I can't use minus pi over 2 to pi over 2 because it's not going to be 1 to 1 there. I got to move over. So the convention for inverse cosine is that we take cosine and we restrict the domain to 0 pi. Okay, so all this is gone. Don't care about that. And all this is gone. Of course, the drill draw. It's supposed to be. This is supposed to be the bottom. I didn't draw it very well. This one is supposed to be right there. This looks a little bit wonky, but I'm going to get it right, like this. Okay. Domain, range, of course, being negative 1 to 1. Okay. Now, when I invert this, this one is always hard for me to picture because we're going around the line y equals x, and that's here. So it's really like weird. So this is pi. So again, my range becomes my domain. So this becomes -1 to 1. And my domain becomes my range. So this is 0, pi. And at 1, okay, at -1, so I should have pi, right? This point in the middle is, of course, at x equals pi over 2. So that's going to come here at y equals pi over 2. And then this point here is going to be that one there, right? And then it's going to be like this. So that is a little bit harder. For me, I have I have a hard time picturing that in my head. I have to really be careful and make sure I don't get it going the wrong way. But anyway, domain is then -1 to 1, and range goes from 0 to pi. So that's sine, cosine, and of course, my last one is tangent. Okay, so tangent of x. Again, tangent, sine over cosine. Right, so boom, 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 boom. It's got these asymptotes. Right, now we've got all these guys out here. My friend tangent. Of course, the sensible thing is just to pick this one in the middle, right? So we restrict the domain to be, yeah, I had that right. I had it written right. -pi/2 to pi/2. In this case, of course, it's an open interval because these are asymptotes. I never get to the pi/2 and -pi/2. Let's just get rid of this other stuff. And because they're asymptotes, so I have this bit here, and my range is just the whole real line. So when I go back to inverse tan, to the graph of inverse tan, that's easy enough to see what happens here. These vertical asymptotes at -pi/2 and pi/2 become horizontal asymptotes. So this is -pi/2 and pi/2. And this guy just does this. Okay. Has a very nice domain, right? Because this is now defined everywhere. And this is very nicely bounded, right? It's bounded between -pi/2 and pi/2. Students may not like inverse tan. A lot of mathematicians like inverse tan. I'm sorry, this is a terrible drawing of inverse tan. It's just going off this way. Sorry. Not my best work. Not my best work. What can I do? At least I can try to make it look like that a little bit better. Any case, it's not a good drawing, but it's a great function. Nice properties, as I said, bounded, defined everywhere. You have two different asymptotes, plus and minus pi/2, depending on whether you're going to the positive or the negative. This is kind of a fun, nice function. And you will see this one pop up in calculus quite a bit, okay? Sine, and I will say that, by the way, I'm not going to do the other three, right? Inverse cotangent, inverse cosecant, inverse secant. I don't think we'll see those probably at all this semester, so I'm not going to worry about them. Primarily, we'll be working with sine, cosine, and tangent, which means primarily we're going to be working with the inverses of those functions as well.